Okay. Good morning, students. Myself, Professor Veeran ST. I would like to today. I would like to explain the next topic from the subject solid mechanics for mechanical students. So, students, in previous lecture, learned what are the types of stresses, what is stress, what are the SI units of stress. So I just revise within minutes. What is stress, students? Stress is nothing but the force upon applied area. That is sigma is equal to P by A. Is nothing but stress. Stress is nothing but sigma is equal to P by A. Is nothing but stress. And we know that the internal resistance set up per unit cross-sectional area is called as stress, which is also called as intensity of stress. And also the SI units of stress, that is SI unit of stress is Newton per meter square, because load is in terms of Newton, unit of load is Newton, and area of cross section is meter square. Means the SI unit of stress is Newton per meter square. So next topic from the solid mechanics subject is normal stress and types of normal stresses. So normal stress is nothing but the stresses which are at normal to the plane on which forces are act is called as normal stress. So next important topic from the subject solid mechanics is normal stresses or normal stress. Normal stress. So students, what is meant by normal stress? The stresses which are act. What is meant by normal stress? The stresses which are at the stresses which are at the stresses which are at normal to the plane, normal to the plane, normal to the plane on which forces are acting, normal to the plane on which forces are act, called as normal stress, called as normal stress. So what is meant by normal stress? The stresses which are act normal to the plane on which forces are act is called as normal stress. For example, suppose a member or body, suppose this one is the body, then we apply some forces. These forces are acting on the same plane. This P applied force, this P applied force is acting on the same plane is called as normal stresses. Again, there are two types of normal stresses, tensile stress and compressive stress. So tensile and compressive. So tensile means what? When we apply two equal opposite pulls to any body and it increases the length of the body is called as tensile stress. So tensile stress, the types of normal stresses. Types of normal stresses are types. There are two types of normal stresses. There are two types of normal stresses. First, tensile stress. Tensile stress. And second type of normal stress is compressive stress. Compressive stress. These are the two types of normal stresses, tensile stress and compressive stress. So tensile stress, first, tensile stress means what? Tensile stress is nothing but when we apply to equal opposite pulls to any body, and it increases the length of the body is called as tensile stress. For example of tensile stress. A body, suppose a body, when we apply two equal opposite pulls, means when we apply two equal opposite pulls to this body, it increases the length of the body. When we apply two equal opposite pulls to the body, this P pulls means what? When we apply a load P, when we apply load P, two equal opposite pulls applied to any body, then what happens? The length, this increased length is nothing but increased length of component or body. This is nothing but increased length of body. Means tensile stress is nothing but when we apply a two equal opposite pulls to a body, then it increases. The properties of that body are what? Lengths are increased or lengths are increases. So this is nothing but tensile stress. Then second type of stress is what? Compressive stress. So what is meant by compressive stress? So students, normal stress means what? The stress which are act normal to the plane on which forces are act is called as normal stress. In this second type of normal stress is compressive stress. Again, in compressive stress, we know that suppose a member, suppose this one is the member. When we apply two equal opposite pulls to this member, what happens? Which property is going to be changed? Suppose when we apply some two equal opposite push to a body, when we push, suppose this one is our body. When we push to this body means what? We have to apply a pressure or apply a load. Means in that case, when we apply push to a body, suppose P, load applied to a body, in that case what happens? The length of that component is decreased. This one is the decreased length. Length of component goes on decreases. Why? Because we apply some internal or some force or some applied force, that is, when we apply some push force to that body, then the length of that component goes on decreases and area of cross section of this body is increases. This is nothing but compressive stress. So what is the difference between tensile stress and compressive stress? That is, in case of tensile stress, we apply two equal opposite pulls to a body. In that case, what happens? Which property? Length. The length of that body goes on increases and area of cross section goes on decreases. And in case of compressive stress, what happens when we apply some two equal opposite pushes to a body? Then when we apply some push force to a body, what happens? The length of that body goes on decreases and area of cross section increases. This is called as compressive stress. So these are the two important types of normal stresses: tensile stress and compressive stress. Again, next type is what are the types of or what is strain and what are the types of strains. So next topic is strain. Next topic is strength. So what is mean by strength? So strength is nothing but change in dimension to the original dimension is called as strength. So what is strength? Strength is what? It is a ratio of. It is ratio of change in dimension. Change in dimension is the ratio of change in dimension to the original dimension. To the original dimension of any body or component. So what is strength? Strength is nothing but change in dimension. That is change in dimension to the original dimension. To the dimension is called as strength. Is called as strength. Again, there are three types of strength: tensile strength, compressive strength, and deformation. These are the three types of strength. So, what is mean by first tensile strength? So, what is mean by tensile strength? Tensile strength is the type of strength. Tensile strength is nothing but it is the ratio of increase in length to the original length. So what is tensile strength? Increase in length. Increase in length. It is the ratio of increase in length to the original length. Increase in length to the original length is called as tensile strength. Then second type of strength is compressive strength. So what is compressive strength? Compressive strength is nothing but what? It is defined as the ratio of decrease in length to the original length. It is defined as the ratio of decrease in length to the original length. To the original length is called as what? Compressive strength. Tensile strength is nothing but increase in length upon original length. Compressive strength decrease in length upon original length. And third, deformation. Third type of strength is deformation. So what is deformation? Deformation is nothing but when the body is subjected to some external forces, it undergoes changes in its shape, size and shape, which is known as deformation. So what is deformation? Deformation is nothing but when the body is subjected to some external forces, it undergoes changes in its size and shape, is called as deformation. So these are the three types of strength. So what is strength? Strength is nothing but change in dimension to the original dimension. What are the type of strength? Tensile strength, compressive strength, and deformation. What is tensile strength? Tensile strength is nothing but change or increase in length to the original length. Compressive strength, decrease in length to the original length, and deformation is the third type of strength. Next, Hooke's law. Next topic, is Hooke's law. What is Hooke's law? Next topic is Hooke's law. Hooke's law. So what is Hooke's law? For example, suppose when we plot a graph of stress strain, consider stress on y-axis, strain on x-axis. Suppose Hooke's law is proportional limit. So what is Hooke's law? The statement of Hooke's law is nothing but when a material is loaded within its proportional limit, when any material is loaded within its proportional limit, then the stress is directly proportional to strain. Is called as Hooke's law. What is Hooke's law? What is the statement of Hooke's law? When the material is loaded within its proportional limit, then the stress is directly proportional to strain. Means stress is directly proportional to strain means what? Suppose stress is directly proportional to strain, and we denote the stress as sigma and strain as E. That is, stress is directly proportional to strain, and the sigma is nothing but constant into E. Means this sigma by E, this ratio sigma by E is nothing but is equal to constant. Okay, relation between stress strain, that is sigma by E is equal to constant. So this is Hooke's law. What is Hooke's law? Hooke's law is nothing but when any material is loaded within its proportional limit, then stress is directly proportional to strain. So today learn what is strain, what are the types of strain, then what is Hooke's law. So in tomorrow's lecture, we'll see next part of this unit number 1, that is simple stresses and strain. That is for ductile or brittle material, stress strain diagram for brittle and ductile material. So today we stop here. Thank you.